Here we are in Chapter 3 review exercises numbers 38 through 42. Here it says sketch the graph of the following functions. These functions are ones that we have done throughout the chapter that we're becoming familiar with. So we'll do a little bit of it to make sure we understand where the plots go and then see if that jogs our memory. And if you don't remember it so well, go ahead and stick in more numbers than I'm going to. So we do know that if we stick in 1 and -1, let's go ahead and write this little something to get us started, 1 and a -1 and maybe a 2 and a -2 to see where it's going. If we stick in 1, 1 over 1 is 1. 1 over -1 is -1. 1 over 2 is 1/2, and 1 over -2 is -1/2. So that gives us 1, 1 as a point, -1, -1 as a point. You're like, from those two, it could be going anywhere. But now we see that 2 and 1/2 and -2 and -1/2. So they're kind of mirror images of each other. Now let's stick in some more to see where it would go. If you stick in 3, you get 1/3. So 3 would get even closer to 0. 4 even closer, 1/4. And you see we end up going like this. Yeah, now that starts to bring back memories. If we stick in a -3, we get -1/3, closer to 0, -4, -1/4. And so it heads up this way and then gets closer and closer to 0. Now let's think, what happens if we start sticking in numbers in here, close to 0? Well, 1 over a 10th is 10. So a very small number will yield a very big number. And that's where we get the idea that we saw this with slopes. You cannot stick in 0. This one will head down here. -1/10 will produce a -10 when you reciprocal it. Yeah, so 0 is not part of the domain. There's no y-intercept on this particular function. Good. Okay, absolute value of x. Let's do the same thing. You'll notice on this one, you stick in a 1 and a -1 and a 2 and a -2, and what happens? You get +1, +1, +2, +2. Let's graph those and see what happens. Oh, we could actually stick in 0 on this one and be okay. So 0, 1, 1, 2, 2, and you stick in any positive number, you get that same thing out. So 3, 3, 4, 4. You get a straight line that way. And if you stick in -1, you get +1. -2, you get +2. -3, you get +3. And you end up with a V shape. So 1 over x forms this kind of mirror image shooting up and down of each other. Absolute value forms a V. Okay, then what? B of x equals x cubed. Okay, so let's try a couple of those. Let's do the -1 and 1 and -2 and 2, and 0 is okay being stuck in this one. So 0 we stick in and we get 0. -1 cubed is -1. 1 cubed is 1. So it's very interesting. 1, 1, 1, -1 happened on this one up here, number 38 as well, but there was no way to connect them because you couldn't stick in 0. This one, we are going to connect them with a shape. -2 goes to -8. And you'll notice this is what tells us it's not a straight line. -2 all the way down here at -8. This is a curve like that. And so it's going to head up, and then 2 gives us 8. So that'll keep going up here. 2, 8, and 327. Kind of looks like a chair going in here. Yeah, there we go. Like that. Good. And then number 41. Here we have t of x equals x squared. Let's go ahead and give ourselves a few to go with. -1 and 1 and -2 and 2 and maybe a 0 in there. Yeah, 0 can go in there. -1 squared is 1. 1 is 1. You'll notice it looks just like absolute value of x. 0, 0, 1, 1, 1, -1. Notice what happens when we stick in the -2. -2 squared is a +4. So you'll notice it doesn't carry on in a straight line. 2, oh, -2, 4 is over here. 2, 4 is over there. They do hit the same height there. And then 0, 0. So we have a point. And so you'll notice it's not a straight V anymore. It's kind of a curve up. It's a U shape, if I can do it. There we go. Excellent. And so these are the fundamental graphs, and when you get into pre-calculus, you'll start off identifying these, and they will become second nature to you. Chapter 6, we will revisit number 38 as well when we do rational functions, putting x's on the bottom. And it causes a problem every time it happens. Okay, number 42. For the following function, modeling growth of an investment account with 9% interest, you'll notice there's the 0.09 in our problem right there. Compounded monthly means you divide it by 12, take that much interest, add it into the whole thing, and then 12 times the number of years, x represents the number of years, so 12 times that will be the whole total number of months that are compounded. So this dividing by 12 and timesing by 12, that's how you know it's compounded monthly. All right, so let's stick it in. We stick in 0, and we get a of 0 equals 3,000 times 1 plus 0.09 divided by 12, all to the 12 times 0. This is all, do you remember anything to the 0 power is 1. So 3,000 times 1 will just give us 3,000. That is true, that is true. Now it's going to be interesting if we stick in a of 2, that's our next one. 3,000 times 1 plus 0.09 over 12, all to the 12 times 2. Let's go ahead and pull up our handy-dandy calculator and punch this guy in. We get 3,000 times parentheses 1 plus 0.09 divided by 12, and that is all to the 12 times 2. Now remember, make sure that 2 is in the parentheses up top, otherwise it'll take it to the exponent of 12 and then times the whole result by 2, and we'll get something different. We end up with 3,589.24, 3,589.24. And you'll notice in the first 2 years, whoever this was made about $589 there. Okay, that's great. On this calculator, we have a nice ability to do this. We can hit second entry and it types the whole thing out for us. So all we need to do now is say, oh, let's put a 5 right there. Notice all we're doing is changing the x value. When we change the x value, that's all we're doing. We stick in 2 here and 5 here, and everything else remains the same. We now get 4,697.04, 4,697.04. You'll notice in the next 3 years, they made over $1,100 instead of just $500 in 2 years. It over doubled how much they had made previously. And here we have the compounding of interest. So let's go ahead and finish these out. Let's stick in 10. Ooh, let's look really quick here. In the first 5 years, he made almost $1,700. Let's see what the next 5 years does. Second entry, and here it's going to be 10 and a parentheses. Ooh, 73.5407. 73.54.07. In the first 5 years, he made about $1,700. In the next, he made about $2,700, 26 something. That's pretty impressive. It's growing faster and faster. All right, the next 5 years, stick in a 15, so second entry, and move that back and stick in a 15, and we get 11,514.13. 11,514.13. Notice the next 5 years, he made over $4,000. Wow, growing fast. This is what exponential growth is all about. So the next one, second entry, and change that 15 to a 25. And this is really a great illustration of what a function is. Oops, yeah. Oh, that was 10 years later there. Phew. It just inputs and changes the one number, and you see what the output is. So 28,225.24. 28,225.24. Good. Notice in the first 10 years, he made $4,300. In the next 10 years, he made about $21,000. Wow. And then the last one, let's do 35 and see where he ends up when he's ready to retire. Second entry, and 35 goes right there. Enter. 69,190.15. 69,190.15. So that $3,000 that he started with, obviously he'd be adding to it if this was a real retirement account, but $3,000 turned into almost $70,000 over 35 years being left in a mutual fund, growing at a moderate rate there. Excellent. Oh, it does say to sketch a graph of the function. Okay, yeah, we're not going to be totally exact with this, but this will help us do it. So we've got to go from 0 to 35, so 10 years, 20 years, 30 years, 40 years. So that's about 35 where we're going to end up right there. 10, 20, 30. Okay, so there's 25 and 15 and 5. And then we've got to make it up to 70,000. So that means 1, 2, 3, 4, 5, 6. So about 60,000 there, 50,000 there, 10,000 there. Okay, that should allow us to do it. So at 0, we're at about 3,000. 2 years, just barely above that. 5 years, we're almost $5,000. 10 years, we're at 7,000. 15 years, this doesn't appear to be growing very fast at all. So we're at 11,000, so at least we're above that number right there. And then 25, we're up at almost 30,000. So here's our 30,000 mark. 25 and almost 30,000. See how it starts to really pick up? Exponential growth here. And then 35 is up at 70,000. So it ends up looking like this. And that's what exponential growth is. And it probably has some wiggles in there if it was in a mutual fund. All righty. Excellent. That's 38 through 42.